Isotopes. Isotopes are variants of a chemical element that have the same number of protons, which defines the element, but a different number of neutrons in their atomic nuclei. These variations in the number of neutrons lead to differences in atomic mass for the same element. Here are some key details about isotopes. Atomic number and identity. The atomic number of an element is equal to the number of protons in its nucleus. It defines the identity of the element. All isotopes of the same element have the same atomic number. Atomic mass. The atomic mass of an element, as listed on the periodic table, is an average of the masses of all its naturally occurring isotopes. This average takes into account the relative abundance of each isotope in nature. Therefore, the atomic mass may not be a whole number, even though the mass of individual isotopes is whole numbers. Isotopes and neutrons. Isotopes of the same element have varying numbers of neutrons. Neutrons are electrically neutral particles found in the nucleus of an atom. Protons and neutrons together contribute to the atomic mass. Stable and radioactive isotopes. Stable isotopes. Most isotopes are stable, meaning they do not undergo spontaneous radioactive decay. They have a balanced ratio of protons and neutrons, making them relatively stable over time. Radioactive isotopes. Some isotopes are radioactive and undergo decay, emitting radiation in the form of alpha particles, beta particles, or gamma rays. Radioactive decay can be used for various applications, such as dating archaeological and geological samples, radiocarbon dating, uranium lead dating, medical imaging, PET scans, and nuclear power generation. Common examples. Carbon. Carbon-12, Ca-12C, is the most common and stable isotope of carbon, with 6 protons and 6 neutrons. Carbon-13, Ca-13C, is another stable isotope of carbon with 6 protons and 7 neutrons. Carbon-14, Ca-14C, is radioactive and is used in radiocarbon dating. Hydrogen. Hydrogen-1, Ca-1H, is the most common isotope of hydrogen, with a single proton and no neutrons. Deuterium, squared H, is a stable hydrogen isotope with 1 proton and 1 neutron. Tritium, cubed H, is radioactive and has 1 proton and 2 neutrons. Applications. Isotopes have numerous applications in various fields, including medicine. Radioactive isotopes are used in medical imaging, e.g., PET scans, and radiation therapy for cancer treatment. Geology. Isotopic dating methods help determine the ages of rocks and minerals. Nuclear energy. Certain isotopes, like uranium-235 and plutonium-239, are used as fuel in nuclear reactors. Agriculture. Stable isotopes are used to study nutrient cycling in plants and ecosystems. Environmental science. Isotopic analysis can track the movement of pollutants and elements in the environment. Archaeology and anthropology. Radiocarbon dating helps date ancient artifacts and human remains. Isotopes are a fundamental concept in chemistry and play a crucial role in understanding the behavior of elements and their applications across various scientific disciplines.